Okay, so I am going to be walking through two example problems of the antiderivative involving inverse trig, and I am just doing the inverse tangent. Just before I even start doing these two example problems, the first thing I want to say that helped me kind of memorize this equation is to remember that in the inverse tangent equation here, the little thing that I remember it is, you see the plus sign here it's kind of, the t and the plus sign, that's just like a little thing as to how I remember to use the inverse tangent when we look at like this example problem here. So yeah, let's just jump right into it. So we've got the integral of 8 dx over 7 plus 9x squared, and the first thing we're going to do is write out our u squareds and a squareds. So our u squared is 9x squared, and the u squared is always the one that has the exponent, and then so u is going to be 3x, a squared is 7, and a is the square root of 7. And now we're going to find our du. So du is equal to 8 dx, and so 1/8 du is equal to dx. And now let's go ahead and put in our information we have. So we're going to take this 8 out here, and we're going to move it in front of the integral. So now we've got 8 like that. Just like that. We're just plugging in our information. And then 8 times 1/8. Now we're just plugging in our du's, our a squareds, and our u squared. And I got the 1/8 from the 1/8 du over here. So now let's go ahead and solve it. So we've got 1 over square root of 7, and square root of 7 is a, and we've got 1 over a, inverse tangent, and u is 3x over a, 7, plus c, big F of x. And that is the answer for number 1. Okay, so now I'm just going to do another example problem. So I'm just going to go ahead and jump right into it and get u squared and a squared. So u squared is x minus 2 squared, and u is x minus 2. A squared equals 4, and so a will be 2. Alright, we're going to put 3 here. Now we're just plugging in our du's, our a squareds, and u squareds here, like that. And then 3 times 1 over 2, getting our 1 over a, inverse tangent, u over a, x minus 2 over 2, plus c. And then we're just going to do f of x, 3 over 2, inverse tangent, so minus 2. And the reason we did not find du is because the dx is on the outside of the fraction, so we did not have to find du. We could easily just put 3 in front of the integral and just put du on top of the fraction. And that's it.